Hello everyone, welcome to today's class, today's math tutorial. Before us here we have a Japan math Olympiad question, and the question is x plus y plus z equal to 3. This is given as equation 1, x squared plus y squared plus z squared equal to 1. This is given as equation 2, and x to the power of 3 plus y to the power of 3 plus z to the power of 3 equal to minus 3, given as equation 3. What then will be the values of x, y, z? So if you've not subscribed, this is Math Prowess, where we roll out tough math solutions all the time. So do it to subscribe. And when you subscribe, turn on the notification bell so that you get notified whenever we drop an amazing video, amazing math challenge that will benefit you. Okay, so let's go into today's challenge. So we'll take the first thing, solution. I'm going to solve this math problem step by step. Yeah, so don't go away, relax. So what is the first thing we do here now? From our algebraic identity, we can rewrite equation 2. Okay, so we have x plus y, all right, plus z all squared. This is equal to our x squared plus y squared, then plus z squared plus 2xy plus 2xz. Sorry, here is yz, please, plus 2yz, then plus 2zx. You remember this? So from here, you discover that 2 is common to everything here. So let's go ahead and factor out 2 from here. So we have x squared plus y squared plus z squared plus 2 into our xy plus yz plus zx. Close bracket. Are we learning something here? Yes. So we can move the whole of this to this side of the equation, right? So this now implies that our bracket x plus y plus z squared, this will turn to minus 2 bracket xy plus yz plus zs close bracket equal to, we are left with this, which is our x squared plus y squared plus z squared. Now let's look at this together now. You discover we're having x plus y plus z here, and we're also having this. So the whole of this is 3, given to be 3. Then again, look at what we have here. This expression we have here now, x squared plus y squared plus z squared, we're having it here. So the whole of this is given to be 1. So let's go ahead and substitute. So this will now give us 3 squared minus 2 bracket x y plus y z plus zx equal to 1. This will give us 9, right? So we move the 9 to this other side, or we can move everything to this side there, bring this to this side. So we're not going to have here 9 minus this is this equal to our 2 bracket x y plus y z, then plus zx, right? Then here will give us 8. So we have here 8 is equal to 2 bracket x y plus y z plus zx. Divide both side by 2. So we equally divide this side by 2. So cancel, 2 here, 1, 2 here, we have 4. So we are having our x, y plus y, z plus zx equal to 4. Let's keep this expression here because it's very important. We are going to make use of this. Let's give this one equation star. Again, from our algebraic identity, look at this guy here. We can rewrite this from our algebraic identity. We know that our x to the power of 3, there plus y to the power of 3 plus z to the power of 3. This is equal to, bracket open, x plus y plus z, close bracket, the bracket, x squared plus y squared plus z squared, then minus xy minus yz minus zx, close bracket, then let's continue here, plus 3xyz. Okay, are we learning something here? Good. So let's go systematically. Now, again, you discover that we have this already to be what? To be minus 3 here from the equation 3. So this is minus 3, right? Now, again, we have this, which is, okay, let's just put it here, x plus y plus z, which is this to be 3. So here we have this to be also 3. Want to substitute again. And again, we can bring out minus here. So if we bring out minus here, we have something like this already from our equation. Before we bring out this, let's just substitute this and see what this gives us. So we're going to have minus 3, right, equal to our 3, then into x squared plus y squared plus z squared minus, I want to use minus to open up everything here. So yeah, bracket here, x, y plus y, z plus zx, right? Close bracket, there plus 3x, y, z. Again, we know that our x squared plus y squared plus z squared is given to be 1. And again, we know that our xy plus yz plus zx will solve for it to be 4 already. So we know the whole of this is 4, the whole of this is 1. So if we substitute again, this now implies that our minus 3 is equal to 3, the bracket 1 minus 4, close bracket, plus 3xyz. Okay, we are heading somewhere. So our minus 3 will now be equal to 3. Then here we give us times minus 3 plus 3xyz. Wow. So we have minus 3 is equal to minus 9 plus 3xyz. Let's continue. This will now give us minus 3 plus 9 equal to 3xyz. So we're going to end up having 3xyz equal to 6. Divide by 3, divide by 3. This leaves the system. So now I have xyz is equal to 2. So we've also established an important equation that will enable us to solve for the other. So let's give this equation star star. Now from equation star and equation star star, there plus the first equation, which is equation 1, we want to create a polynomial of a third order degree. Okay, so how do we do that? It's very easy, but before then, let's bring out the 3 equations we are going to use to create the third order polynomial equation. So we have here we have equation 1, so we have x plus y plus z is equal to 3. Remember, this is our equation 1, right? Then we have our x, y plus y, z plus z, x equal to 4. This is our equation star, and our x, y, z equal to 2. This is our equation star, star. You remember this? So we want to form a third order degree polynomial equation from this. This is the only way we can solve for the value of x, y, and z. So how are we going to do this? Watch what I want to do here now. Very easy and crazy something you're going to learn. Crazy idea you're going to learn from here now. So forming the polynomial equation is going to give us, let's form it in P. So we're going to have here P to the power of 3 minus bracket our X plus Y plus Z close bracket into P squared there plus bracket X, Y plus Y, Z plus Z, X, the bracket P, the minus X, Y, Z, everything equal to 0. Have you seen a thing of this kind before? You are learning something here, right? Okay, so we know the value of this, we know the value of this, we know the value of this, right? Good. So from these equations here, so this now implies that our P to the power of 3 minus 3P squared plus 4P then minus 2, right? Equal to 0. So this is the polynomial equation I told you that is going to be of third order degree, right? So how do we solve this polynomial equation? First of all, we use the trial by error method to get the first factor. And if you use the trial by error method, we're going to get our P to be positive 1. In other words, P minus 1 is a factor, okay? It's a factor of the above polynomial. So if it is a factor, let's use the long division method to get the other two factors. So how do we do this? It is very easy. So let's draw our division sign like you did in your elementary mathematics. So let's put the dividend inside, then P squared plus 4P minus 2. There the divisor will come out, which is P minus 1. So how do we get the quotient here now? The quotient is the quadratic equation we are looking for, right? Good. So let's go. We use this P to divide this P to the power of 3. That will give us P squared. So we have here P squared. Use this to multiply everything here. This will give us P to the power of 3 minus P squared. So we bracket this, and we subtract. So this will leave the system. Automatically, this will give us a plus sign. So we have minus 3P squared plus P squared. That will give us minus 2P squared. So we have minus 2P squared, right? Bring down this. So this will now give us plus 4P. Okay. Again, we use this to divide this. This will give us minus 2P. Yes, that will give us minus 2P. So we use this minus 2P to multiply this. So this will give us minus 2P squared. Then this time this will give us plus 2P. So plus 2P. Again, we close our bracket and we do our subtraction. Right? Good. Let's introduce our minus. So here gives us plus. So this will leave the system. Here will give us a minus. And so 4P minus 2P will give us 2P. We bring the last term down here, which is minus 2. Again, we use this to divide this, and that will give us plus 2. So here, when I have here to be plus 2. We use this to times everything here. This will give us 2P, then minus 2. We rule off. Again, let's introduce our minus sign. This will leave. This gives us plus. So minus 2 plus 2, this will also leave. So we have 0, 0. At the point where we have 0, 0, let's bring out our quotient. So our polynomial equation thus implies that our P minus 1 close bracket, P squared minus 2P plus 2, everything equal to 0. So our case 1 does not have issues because we are having P minus 1 equal to 0. We also equate this to 0. So case 1, we have our P minus 1 equal to 0. So therefore, our P is equal to positive 1. So we've gotten the value for P1 now. All right, so let's look at case 2 critically. This is a quadratic equation, and we cannot solve this using the factorization method. So what we do, we use the formula method. So our formula says that P is equal to minus B plus minus the square root of b squared minus 4ac all over 2a. So let's bring out our a's. From the equation, a is equals to positive 1, b is equals to minus 2, and c is equal to positive 2. So let's quickly substitute into our formulas. So we have here p will now be equal to minus bracket minus 2 close bracket plus square root and minus rather. So we have minus 2r squared minus 4 bracket 1 bracket 2, right? Yes, everything all over 2 bracket 1. So this will now give us here your positive 2 plus minus the square root of 4 minus 8 all over 2. Oh, it's still long. Okay, so what we do here now, it is easy. Let's subtract this. So this will now give us 2 plus minus the square root of minus 4 all over 2. Again, remember that the square root of minus 1 is equal to what? Iota. So we can bring out iota here. And the square root of 4 is 2. So this is same thing as 2 plus minus 2 iota all over 2. So if we factor out 2 from here, they use 2 to cancel out. We are left with 1. So our p automatically is going to give us here 1 plus minus iota. Okay, so if this is our P1, P2, because we have 2 of it here now. So we now have our P2 here is equal to 1 plus iota. And P3 is equal to 1 minus iota. So let's go ahead and bring out the values of our P1, P2, P3. So we can now say, or this now implies that our P1 is equal to, we solve our P1 already. For now, let's check it out. Okay, so look at our P1. Our P1 we solve to be positive 1. So we have P1 is equals to 1, and P1 is equivalent or is equal to our x. Then P2 is equal to 1 plus iota, which is equal to our y. Then P3 is equal to 1, please, 1 minus iota, which is equal to z. So we can now conclude by saying that therefore our x, y, z will now be equal to bracket open 1, 1 plus, let me write the 1 very well, 1 plus iota, 1 minus iota. All right. Okay. So this marks the end to this wonderful Japan Math Olympiad question that has really taken almost all our time. Okay, but I believe we'll learn something from this video tutorial. So if you learn something from this video tutorial, give the video a thumbs up. If you have a better way of solving this, then leave it in the comment section so that we can equally learn from you. Or you have a question with regard to the solving in one of the steps you are not clear, please don't hesitate to drop it in the comment section. We are good at replying to comments. Thanks for being there. Until we see you again in our next class, stay safe. Bye for now.